Very expensive.
Okay, so today I'm going to teach you Laplace transformation. So before that, what exactly is Laplace transformation? Or what in the world is Laplace transformation? Well, before we dig into Laplace transform itself, I would like you to bear in mind three things. First is transformation and operators. Basically, if you have transformed, if you have a function f of t, what you do in transformation is that you get a function of s. In operators, if you have a function of t, then basically you will get a function of t but at a different function. So if you have an example, like for example f of xy, you convert it to f uv. So basically the experience that I did before. In an operator, examples are like gradient, divergence, curve, or basically the d by dx, or this class. And so let's say if you have f of t, then if you get the derivative of f of t, then you have g of prime f prime of t. That basically is g of t, a different function. So that's the first thing I want you to bear in mind. The next thing is sequence and series. Well, if you have a sequence function, basically sequence are just this. So these are sequence function, and the series functions are, well, if you are in this cube of n, then sequence and series. The third one I want you to bear in mind is integration of improper integrals. So in Laplace transform, I want you to, well, improper integrals are those integration that involves integrals having zero denominator and of course boundaries such as 0 to infinity, negative infinity or infinity, etc. So let's try to recall from math 52 how to get the integral of a function dx, function x from 0 to infinity. So basically what we do is we get the limit, we change the infinity to n and we get the limit of n as it approaches to infinity. So let's try to solve one problem. Let's say f of x is equivalent to e to the negative x. So if we try to evaluate this one, e to the negative x dx, then basically we have as n approaches infinity. So this is n, then e to the negative x dx. So if we try to evaluate this integral, we have e to the negative x, then negative from 0 to n. So if we have limit of n which is infinity for the e to the negative x from 0 to n, then we basically have e to the negative n plus 1. Do you agree? Yes. Yeah. So this is basically 0. So we have 1. So let's take the equation by integration by self-improper integrals. So before I proceed, any questions? So, okay. Now, let's go to the main agenda. Well, I want you to consider a power series. So A of n, x raised to n. So this basically is power series by this is a series, a discrete summation. It's just that x is raised to a power n. So that's why it is called power series. So what you get in this equation, if we evaluate that, is let's say a function a of x. So if you try to figure this out geometrically, you have basically a of 1 x raised to 1. I'm sorry, I forgot. A of 2 let's say a of n x raised to n. So here, this is a of 0. So when n equals 0, when n equals 1, when n equals 2, and when n equals n. So basically, the area under this graph, or under this, or the sum of the area of those boxes, are what is meant by this discrete summation. So what if we have a continuous function, or let's say, what if we have this kind of graph function? How are we going to get the area under the curve? Well, if you have this, we can convert this to a Riemannian sum or Riemannian sum notation, which is here the values here are, well, n equals 1 and 2, then for this function, I'm trying to get the domain of t from 0 to positive infinity. So this is equivalent to saying that this function is from 0 to infinity, f of t x raised to t dt. So what I did here is I just changed the a to f and then the n to t.
The limit of change of t approaches 0, where in fact your limit of t is
No, this is delta t. So if you take from two t's like t1 and t2, so if you get their difference, they are approaching to 0. So that is basically calculus. So any questions? Am I clear enough? So let me see. Yeah, so now we have this function. Well, what do you notice in this function? Can you integrate it? Integrate money. Anyone? Well, basically, integrate money, but well, generally speaking, you don't want to integrate functions that are exponential in nature, but whose base are not e. So try to notice this one. It's difficult really to integrate this with base x. So we will convert this x to the natural log. So how are we going to do that? Well, by properties properties of logarithms, we have x equals e to the ln x. So, I think no need to prove. Well, x equals e to the ln x. Now, if we try to, for x raised to t, then this becomes e to the ln x raised to t. Sakto? Now, remember that this function is an improper integral and we're trying to integrate this from 0 to infinity. That means there's a possibility that the integral may be divergent or convergent. So, divergent in physics doesn't mean anything. I mean, they are meaningless. They approaches infinity and thus we cannot say its physical meaning. So we'll consider the case when this equation is convergent. So when does this become convergent? Well, let's say x, let's have the value of x 2. So like 2 raised to infinity. That's what? Infinity. So infinity, if it's infinity, then it's divergent. Let's say negative 1 half. No, let's say 1 half. 1 half. Diba, it approaches, the value becomes smaller and smaller and it approaches to a certain value. So, well, it's convergent. Let's say negative 2. Negative 2, well, if we raise it to 1 half, then what we have is square root of negative 2. And that's imaginary. So, we limit the values of x. So this values only. So, from 0 to 1, but not including 0 and 1. So this implies that ln x must be greater than 0. Would you agree? Agree mo? If you try to get ln 1 half, then you get negative 0.693, diba? And then 0 is for infinity, but we don't consider 0. But if you get ln 1, then if you get 1, then basically this value becomes x. It becomes 0. So, what we're because we want the function to be convergent, we need to have x to be between the values 0 and 1, and that implies that ln x should be negative. Questions? So if we to simplify the equation, that equation further, then we may equate this x ln x to s, negative s. Since since we want ln x to be less than 0. So wala negatives here. Now what do we have? Well, if you try to substitute negative x, then this equation will become from 0 to infinity f of t e to the negative st dt plus a function which is f of s. Now this, my dear friends, Laplace transform, denoted by showing f. So, questions so far? Am I making this equation clear? Well, what I'm telling you is how Laplace transform was derived. Because Laplace is temporary and was later used by Oliver Heaviside. Heaviside is a physicist and an engineer. So, questions? Now let's try to use this equation to sum functions. So let's say if you have a function f of what? F of t equals what? So the graph of this function basically is this. Diba? This value is 1. So if we try to substitute it there, then from 0 to infinity, because f of t is 1, and e to the negative st dt, this would be equal to, as we have reviewed a while ago, and this is e to the negative st dt. Agree? Questions? So, evaluating this equation, we have the negative st over negative s from 0 to n. Log your mind. There's negative s because the integral is positive and that it has the constant value s. Next thing that we do is evaluate this equation, and this becomes the limit that's n approaches infinity. Ano over negative s? Try to get the derivative of e negative s. Di ba makagawa ko?
Pero di dapat negative sign din na ano to before sa bar.
That's if you try to get the derivative of e negative s, we get negative s e to the negative s t. So we're trying because the integral is this equation only. So we need to divide the negative s. So mana siya? Mana yung function? Now, negative s, so since with respect to t na ng derivative, so when we evaluate it, the negative sn, and then this becomes minus e to the negative 0 is 1 over negative s. Agree mo?
Yes.
So this becomes, because this equation becomes literally 0, then the function will be equal to negative 1 over negative s. 1 over s. But is this equation or solution for Laplace correct? Or less than 0 degree. This equation will only hold true if x is greater 0. Ano ba? Well, if we try to substitute s by negative 1, may mo siya positive n, positive infinity. And the e raised to infinity is what? It's divergent. So, since nakakita ko ng graph din, the graph of this function is so what if s is negative? Well, as you can see in the graph, walay meaning din. Walay graph, walay curves. So, it's meaningless. Now, this function, as you can see, is one linear, but the Laplace transforms of functions, this one, for function 1, you get 1 over s, but make sure that s must be greater than 0. And then here, e raised to 8t, s must be greater than 8. So, if you want, you can derive this from the Laplace transform in your free time. This is pretty simple. Yeah. And then, these are the properties of the Laplace transforms, but I can't go in deeper to this equation because I think you need to understand the theory on higher order differential equations. So then, but I want you to know these two properties of Laplace transforms because this indicates the linearity of Laplace transform. That means to say that Laplace transform can be used to solve linear differential equations. So, what are powers of transform, Laplace transform? It is, well, according to my source, usually Laplace transforms are used by mostly engineers and some scientists. Engineers because this is just an alternative way of solving differential equations, and I think it is much easier to use this transformation. So questions? Wala?